people who study theoretical physics are looking for a picture of the world. They want to know where they live and seek an image of the world. They want to know where they live. They want to understand the true nature of reality. Such understanding should tell them a lot about themselves since they are part of this world. This seems like a natural requirement for science. Yet all the theories of the last century have failed. Today's physics makes contradictory claims about the world we live in. Because physics is based on two completely different mental models. One is Einstein's theory of relativity, and the other is quantum mechanics, developed by Bohr, Schrödinger, Heisenberg, Dirac, and others. These two ways of thinking are so different that they could never coexist in their present form. According to the theory of relativity, we live in a four-dimensional spacetime. According to quantum theory, we live in an infinite-dimensional Hilbert space. In Einstein's theory of relativity, time is a dimension, so everything that has happened and everything that will happen is already there as an immutable entity. It is an entirely predictable and deterministic view of the world. In contrast, quantum mechanics says the future is open. It can only be calculated statistically based on probabilities. How can these two theories contradict each other so strongly and yet both make correct and accurate predictions? It is because they are used in different realms. Quantum theory is used to describe the behavior of particles in the microcosm, while general relativity is used for big things like planets, galaxies, and black holes. Numerous attempts have been made to find a theory of everything that describes both the large and the small. In such a theory, relativity and quantum mechanics must appear as different aspects of a deeper underlying law. It should be common knowledge that simply applying the laws of quantum mechanics to spacetime gets us nowhere. However, all proposals for definitive theories of the universe still work with these two different sets of laws. In over 80 years of combined effort, no one knew how to combine these laws into a single entity so that they appeared as two different aspects of the same thing, worldviews no longer contradicting each other. Why is it so hard? The main reason is that while physicists understand and embrace the principles of relativity, they have no idea what to make of quantum mechanics. There is no consensus on how to understand its basic principles. To embrace relativity is to believe that time is just a dimension, that the passage of time is an illusion, and that simultaneity is relative. Yet quantum mechanics crucially depends on simultaneity and the passage of time, as we will see later. The essence of quantum theory is not hard to see. It gives the conscious observer a central role. But this role is so difficult for science to accept that it has simply given up trying to extract any concrete worldview from quantum mechanics. As a result, the Copenhagen interpretation, the first and most common interpretation of quantum theory, can represent two kinds of viewpoints. One theory holds that consciousness causes the wave function to collapse, implying that conscious observation leads to a choice between realities, technically given the collapse of the called reality. The other is simply a collection of philosophical ideas that argue that our normal logic and everyday language are not suited to the quantum world, that we shouldn't even seek a worldview, and that all that exists are measurement results. This view is sometimes referred to humorously as "shut up and calculate." Both versions of the Copenhagen interpretation have measurement as their central concept. It is difficult to imagine how to define a measure without conscious observers. If we do not attribute a central role to consciousness here, we leave the Copenhagen interpretation without criteria for what a measurement actually is. Niels Bohr does not seem to have used conscience as a criterion. He figured that somehow the gauge caused the choice, simply because it was macroscopic. However, what to consider macroscopically also depends on the human being. Bohr believed that fixed classical states might somehow be an emergent property resulting from the entanglement of many quantum systems. This is an idea commonly referred to as decoherence theory, which, unlike the Copenhagen interpretation, does not involve wave function collapse. Therefore, the only way to get a clear definition of the Copenhagen interpretation seems to be to include consciousness. If about 50% of physicists say they stick to the Copenhagen interpretation, only 6% of them give consciousness a central role. This means that most of them simply refrain from interpreting it. Indeed, most physicists believe that there is no way to prove the existence of superposition once the interference has been lost, and therefore there is no way to decide experimentally which interpretation is correct. As we will see later, this view could not be further from the truth. The shut up and calculate approach to quantum mechanics reflects the idea that all quantum philosophy is futile and that we shouldn't be looking for a worldview. Bohr accepted quantum mechanics, but Einstein could not accept them. He told Bohr, "I just can't believe the moon isn't there when I'm not looking at it." This mental barrier has caused theoretical physics to stagnate in some places. The origin of this barrier is a materialistic mental framework and the belief that consciousness is based on pure calculation. That cannot be true, according to formal logic experts. You shouldn't limit yourself to this simplistic worldview. To advance theoretical physics, we must open our minds to the possibility that reality is far more complex than can be captured by a purely materialistic approach. To stay up to date with our latest videos and to unravel the amazing things about our universe, make sure to subscribe to the Victory Path YouTube channel by clicking the subscribe button below the video. Thanks for watching.